Well, as you can see, we've got our golden rectangle down there for a starting spot. And this time I'm going to use my compass from the top up here and measure the length of my short side of my golden rectangle, right about like that. And I'll swing the arc out into the center of my golden rectangle, this way. And I'll do the same thing from the other corner over here, like that, and find out where they cross. And right there, where those cross, I have the makings of a triangle using the proportions of the golden rectangle. Let's see here. What would that look like now if I were to connect that spot with the corners up here? Let's see here, like that. And like this. There we go. Ta-da! Well, years and years ago, somebody looked at that rectangle and recognized something. Let's see if, I'm sorry, with the triangle and recognized something. Let's see if we can make a copy of that triangle on the other sheet of paper over here. First of all, I'll need a construction line to begin. I have to start someplace. So let's come on down here and we'll make a nice construction line. There. And what I want to do is copy that line segment down here. Oh, here's a good spot, I guess. We'll start there and we'll measure it off across this way. There. Like so. And we'll come down here in my construction line and mark it off. Boy, I barely left myself enough room there, did I? And right there, this spot over here would be the same as from A to B. The next thing I want to do is I want to get a copy of the side of the triangle. Let's say the one over here on my left side. We'll go from here to here. And that should be 2 from what we did before, huh? That's the same as the length of the side of my golden rectangle. So let me come up here and we'll start on this side and swing it out into the center here. And since the other side was the same length, just double checking that, pretty close. When I swing from the other side, I should get a copy of that triangle on a nice clean sheet of paper so I can mess with it. Let's see here now. What can we do? There and here. Like that. There. Well, what I'm wondering is, could I find a point here that would be equidistant from all of these sides? That would be on the angle bisector of each of the angles. Let's bisect this bottom angle here and see what we get. If I were to swing my arc from here and make it go around from one side to the other, and then from each of these intersections I can swing up here and over here. And if I were to connect these spots from here to here, I think I'd be on the angle bisector there. That's cool. Right through here. Just like that. Alright. Let's get the angle bisector over here, shall we? Let's swing the arc across this way. Something convenient, doesn't matter what. And then we'll swing from this intersection out into the center. And from this intersection until they cross. And they cross right there. So if I was to connect from here over to here, I would have the angle bisector. If I can get my pencil to line up straight, we'll do it. There we go. cool. I wonder if this one right here is going to be on the angle bisector for that one. I bet you it is, but we better double check it because there's human error involved here, and we try to minimize that. Alright, swinging my arc, let's say across here, like that, and then coming out into the center to try to find out where the middle of it is, right into this general area, and from the other side, from here, like so, and lo and behold, if I was to line up this intersection with this angle, guess where it's going to hit? It's going to hit right on top of the other spot, right there. If I can get this thing to line up straight, it will do it. It will do it. Yes, it will. Right through there. So there's my angle bisectors. That just begs to be the center of a circle, don't you think? Why don't we take our beloved little compass here and use this for a center, and then we'll come over to this point right there and all the way around and find this point over here, and let's make a circle. Now this is where my human error really starts to show up. I hope that we get a circle instead of a wiggle. How about that? Look like anything you might recognize yet? Let's extend these sides here so they hit the circle. Like this. And this way also. Like so. And then we can go from here to here, don't you think? Start to look somewhat familiar to you? There. And if I get this to line up straight, it would be better. There. I have a feeling if I had everything absolutely perfectly, I'd end up with a pentagon in here and a pentagram out here, and this thing should divide the circle into 5 equal parts if everything is done correctly. You can take your compass and see how well you did. I don't trust myself. But if this was the case, that all of these things were cut into 5 equal parts, then let's see here. 360 divided by 5 would be 7, 35, and 2. That means that this should be 72 degrees of arc, and this would be half of that, which then would be 36-degree angle. Isn't that something? And these two would be equal to each other. And what do you want to bet they have to turn out to be 72 degrees each, and so forth and so on. There's a lot of things here to talk about. But the proportions of the golden rectangle are used to make the pentagon and the pentagram, and it's an absolutely amazing thing that this thing can reproduce itself over and over and over again. If you ever have a chance to see a mathematical movie made years ago by Walt Disney called Donald Duck and Mathemagicland, take a look at their presentation of this. It's absolutely wonderful.